The National Electrical Code, or NEC, does not specifically prohibit driving ground rods in a crawl space area. However, it mandates that ground rods be driven to a depth of at least 8 feet, which is approximately 2.44 meters below grade, as per NEC section 250.52. A3. Furthermore, the NEC stipulates the materials for ground rods. They must be made of copper-clad steel or stainless steel, and they must be at least 5/8 inch or 16 millimeters in diameter according to NEC section 250.52. A1. Driving ground rods in a crawl space offers a convenient method for fulfilling the grounding requirements outlined in the NEC. Nonetheless, it is crucial to ensure that the rods are driven to the required depth and that they are constructed from the appropriate materials to maintain code compliance and ensure safety. There is an exception. In situations where the soil conditions are not conducive to driving ground rods effectively, alternative grounding methods are permissible, as detailed in NEC section 250.52. A4. This flexibility allows for adaptation to various site conditions while still meeting the fundamental goal of providing a reliable grounding system. Considering the practical aspects of installing ground rods, several factors warrant attention. Firstly, accessibility within the crawl space is paramount. Adequate clearance is needed to maneuver the ground rod driving equipment and to ensure the rods can be driven vertically to the specified depth. Obstructions such as ductwork, piping, or structural elements can impede the process and may necessitate relocation of the ground rods or the use of alternative grounding techniques. Secondly, soil composition within the crawl space should be assessed. Rocky or excessively compacted soil may hinder the ability to drive the ground rods to the required depth. In such cases, alternative methods such as ground plates or chemical ground rods may be more suitable. Soil testing can provide valuable insights into the soil's resistivity and suitability for conventional ground rod installation. Thirdly, proper bonding of the ground rods is essential to ensure effective grounding. The NEC requires that ground rods be bonded together into the main grounding electrode system using approved grounding conductors and connectors. This bonding creates a low impedance path for fault current to flow back to the source, facilitating the operation of overcurrent protective devices and minimizing the risk of electrical shock. Fourthly, protection of the ground rods from physical damage is important, particularly in crawl spaces where they may be susceptible to contact with equipment or personnel. Sleeving the ground rods with PVC pipe or encasing them in concrete can provide added protection and prevent corrosion. Regular inspection of the ground rods and grounding connections is recommended to ensure their integrity and effectiveness over time. Fifthly, compliance with local codes and regulations is imperative. While the NEC provides a comprehensive framework for grounding, local jurisdictions may have additional requirements or amendments that must be followed. Consulting with local electrical inspectors or building officials can help ensure compliance with all applicable codes and standards. Sixthly, documentation of the grounding system is essential for future reference and maintenance. Accurate records should be kept of the location, depth, and materials of the ground rods, as well as the bonding connections and any soil testing data. This documentation can be valuable for troubleshooting and verifying the effectiveness of the grounding system over its lifespan. Seventhly, safety precautions must be observed during the installation of ground rods in crawl spaces. Workers should wear appropriate personal protective equipment, including safety glasses, gloves, and sturdy footwear. The crawl space should be well ventilated to prevent the buildup of hazardous gases, and measures should be taken to control dust and debris. The electrical equipment used in the crawl space should be properly grounded to prevent electrical shock hazards. Eighthly, consideration should be given to the potential for corrosion of the ground rods over time. Soil conditions, moisture levels, and the presence of corrosive chemicals can all contribute to the degradation of ground rods. Using corrosion-resistant materials such as stainless steel or copper-clad steel can help prolong the lifespan of the ground rods and maintain the effectiveness of the grounding system. Ninthly, the size and number of ground rods required will depend on the size of the electrical service and the soil resistivity. The NEC provides guidelines for determining the appropriate number and spacing of ground rods based on these factors. Consulting with a qualified electrical engineer or contractor can help ensure that the grounding system is properly sized to meet the needs of the installation. 10thly, ongoing maintenance and inspection of the grounding system are essential to ensure its continued effectiveness. Ground rod should be periodically inspected for corrosion, damage, and loose connections. Soil resistivity should be retested periodically to ensure that the grounding system remains adequate. Any deficiencies should be promptly addressed to maintain the safety and reliability of the electrical system. In addition to the NEC requirements, it is important to consider industry best practices for grounding. This includes using high-quality materials, proper installation techniques, and thorough testing and documentation. Following these best practices can help ensure that the grounding system is reliable, effective, and compliant with all applicable codes and standards. The proper installation and maintenance of ground rods are critical for ensuring the safety and reliability of electrical systems. By following the NEC requirements, considering industry best practices, and taking appropriate safety precautions, it is possible to create a grounding system that provides effective protection against electrical shock and equipment damage. In summary, the NEC permits the installation of ground rods in crawl spaces provided that they meet specific requirements for depth, material, and bonding. Careful consideration should be given to site conditions, accessibility, and potential hazards. Proper installation and maintenance are essential for ensuring the effectiveness of the grounding system and protecting against electrical hazards. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and standards.